And now we are at question 5, which is trigonometry. So question 5 goes as follows. So you're given a diagram or a sketch. You're supposed to get your answers without using the calculator. But before we get there, question 5.1 says, in the diagram below, you have point P, which is -7:4, is the point in the Cartesian plane. R is a point on the positive x-axis such that the obtuse angle, which is angle POR, is equal to theta. Then it says in 5.1, calculate without the use of a calculator. So from 5.1.1 to 5.1.2, you are not required to use your calculator. Here and there you may use it, but you will mostly use your sketch or your values from your sketch that you are given. And so in 5 point, so I'll quickly just sketch the diagram so that I can get my values first. So I have point P, which is P is a -7:4, and then I have my theta there. Okay, so in order for me to get those values, I need to make a right angle triangle. So I'm going to draw a line that cuts the x-axis, and then this will be my theta. Since we have P, so we know that P is -4:7. -7:4, my mistake. Then, since that's the case, so we know that x is a -7, and then y is a 4. So that means -7 gets to be on the negative x-axis, and then 4 gets to be on that side. And now we need OP. We need OP, which is our first question, which is 5.1.1. It says determine the length of OP. OP is that length from there to P. So you can use theorem of Pythagoras on that right angle triangle. So OP squared, since it's a hypotenuse, so it's going to be OP squared, it's -7 squared plus 4 squared, and then OP is going to be equal to 49 plus a 16, which will give us, so if I say 49 plus 16, 49 plus 16, it's a 65. Then we're looking for OP, not OP squared. Then we're going to root both sides, so we know that our OP will be a √65. So that is the first answer to 5.1.1. Then 5.1.2, it says determine the value, which is the first one, is as simple as tan theta. So the basic thing that you do, you go to your sketch again. You know that tan theta is equal to opposite over adjacent, which is your trig ratios. So it's going to be equal to, your opposite is a 4, and then your adjacent is that -7. So that is the value of tan theta. And then our part B, which is cos theta minus 180. So that is simply a negative cos theta when you're using your reduction formulas or formulae. So negative cos theta, if you go to your sketch again, you know that cos is SOHCAHTOA, right? So it's adjacent over hypotenuse. So our adjacent, so it's going to be negative. Our adjacent is going to be a -7, and then our hypotenuse, it's a √65. So which is, this will be a +7 over √65. that will be your negative cos theta. And now we look at 5.2. So 5.2, it says determine the general solution of the following equation or trigonometric equation. So it's worth 7 marks, which means you have to work your way up until you get to the answer. So you're given sine x times a cos x plus a sine x being equal to a 3 cos squared x plus a 3 cos x. So if that's the case, then you need to find the general solution. But firstly, we must solve this thing using algebra. So if you take note, we've been dealing with algebra left, right, and center. So you need those basic skills of algebra, which means when you factorize, where you look for a common factor, where you simply just look at the end of each side of your equal sign. What do you have? What can you take out of your brackets and all that? So you need to apply those skills in order to master your maths or your algebra anyway. So if you look on the left hand side of your equation, you can see that sine x is common on both sides. So we're going to take sine x outside of your brackets. So we're going to have sine x, then we open our brackets. So we're going to have cos x plus a 1 being equal to, on the right hand side of your equation, you can see that you have 3 cos squared x plus 3 cos x. So meaning that cos or 3 cos x, by the way, is the one that is common in both sides. So you're going to be left with cos x plus a 1. So now that you can see that you have cos x plus 1, cos x plus 1 both sides. If you divide by cos x plus 1 both sides, you would cancel out this cos x and also that other cos x. So now you are left with sine x being equal to 3 cos x. We are looking for the general solution. We are trying to simplify this thing. So we can continue with this equation by having one trig ratio, if that is possible. Well, it is possible, because if we then again divide by cos x both sides, we're going to be left with a tan x, which is when you say cos x divided by, you divide cos x both sides, so you cancel the other cos x, so you're left with a 3. So on this side, you know on your identities that sine x over cos x is a tan x being equal to 3. And now the value of 3 is said to be positive. Now we're going to get back to that. But now we're going to look at where 10 is positive. So we're going to say theta being equal to, we know that 10 is positive on your first quadrant. So our first quadrant goes as follows. It's going to be your reference angle plus K 360. Also 10 is positive where, so we're going to say theta being equal to, we know that quadrant, it's quadrant 3, which is 180 plus a theta. So it's going to be 180 plus our reference angle plus K times 360. So that is where we're going to look at our general solution for this equation. So but before that, we need to find the reference angle that we're going to insert on those two equations there. So to get our reference angle, we're just going to say tan x being equal to 3. So we're going to say x is equal to, so it's going to be a tan inverse of 3. Then when you insert that into your calculator, we're going to have, so let's say 10, or sorry, shift, then 10, then you say 3. So it's going to be a 71.57 if you round that off. So now we can use those equations. So we're going to start with the first one, theta being equal to our reference angle 0.57 degrees plus k 360. So that is the first one. And our second one, which is theta being equal to 180 plus our reference angle. So our reference angle is that 71.57. So we're just going to add 180 to that. So it's going to be, or let me just substitute it first before I add it. So 71.57 plus k 360. So okay, we already got this one. So here it's going to be theta 251.57 degrees plus k 360. So that would be your general solution. So that is how you get your full 7 marks on that equation. So we move on to 5.3. So 5.3 is worth 3 marks. So it's 5.31. That is worth 3 marks. So it's given the identity. So once they give you an identity, they want you to prove the identity. So the first one, it says prove the identity for 3 marks. So let's just copy the identity. It's sine 3x all over 1 minus cos 3x again being equal to 1 plus cos 3x over sine 3x. So we're supposed to prove this identity. So what do we do from here? So I can see that I have 1 minus cos 3x, and then on the other side I have 1 plus cos 3x. If I multiply the two, that will give me a sine squared 3x. But if I look carefully, if I multiply the sine 3x with the other sine 3x, when I cross multiply, then I think my identity is already proven. So if you cross multiply, so you're gonna have sine squared 3x, because if when you multiply those two, and then you're gonna have 1 minus cos 3x times 1 plus cos 3x. So this sine squared 3x has to be equal to 1 minus cos squared 3x. Now this is an identity on its own. We know that 1 minus cos squared x, in our case, or cos squared theta, has to be equal to sine squared theta. But our theta now is 3x. It's 3x both sides. So that means that sine squared x is equal to sine, sorry, not x, but 3x. Sine squared 3x is equal to sine squared 3x. Then our right or our left hand side is equal to our right hand side. So you've already proven the identity. So that is why it is 3 marks, because that one is easy. And now 5.3.2. So 5.3.2. So 5.3.2, which is the last one here in question 5, also 3 marks. So it says determine the values of x in the interval where x is between 0 and 60, for which the identity will be undefined. So for a value to be undefined, we know that if you say a divided by 0, or if you say anything divided by 0 on your calculator, you're going to see it's going to say maths error, or that is when it is undefined. So that means in both sides of our equations that we have to say that, okay, sine 3x has to be equal to 0, and also on the other side of the equation we have to say that 1 minus cos 3x has to be equal to 0 for the identity to be undefined. So if that's the case, if you solve, if you say, okay, let's say, so if you say shift, then sine. So if you say shift and sine, so you're going to have 3x being equal to 0, and then you're going to have 1 on this side. You're going to have 1 minus cos 3x being equal to 0. So let's see. So it's 1. Okay, let me erase that because I wrote that twice. So yeah, since they said that this has to be undefined, so our denominators have to be equated to 0. Yeah, so we done with the first denominator, which is on the right hand side. We equated to 0, and also the other denominator has to be equated to 0, so that the values of x, then, because they wanted the values of x, so the values of x, for us to get it, we're gonna have 3x being equal to 0, which that was our first one, as well as, or 3x being equal to 180. And then when you're solving for x, we know that x here is going to be 0, and then here x is going to be, if you divide by 3, we know that x has to be a 60. So if we go at it again, so x will still be 0, and then x will be 3x will be equal to 360. So when we divide by 3, so that will be 120. But they said that in the interval between 0 and 60, so we won't use that interval. So the only ones that we're going to use are 0 or 60 and 0. So that is how you would end question 5, or that is the end of question 5 on trigonometry.